Hi, my name is Swastik Banerjee and I'm from India. My poster is about the project I did during Wolfram Summer School 2020, that is the implementation of level index arithmetic for very large numbers. So, in the field of scientific computing, a disadvantage of using the standard floating point arithmetic system is that it is prone to overflow and underflow if we start dealing with numbers which is just a little bit larger than the usual, right? So suppose we are trying to compute a huge binomial coefficient, or we are trying to determine the value of a huge power towers to some sense. So how can we get these meaningful results for these computations without having the computer overflowed or underflowed? It turns out that the big integer library used by, say, Java, or even the big num library is in C++, they have a very small upper bound of the size of bits they can hold. These are okay when you're dealing with competitive programming, say, or some machine learning models where your data set is still limited. But when you're dealing with things like, say, hypergraphs or binomial distributions, it's often hard to find a way to manage these overflows when the number of discrete objects you're dealing with becomes exponential, right? Well, for quite a long time, many people have suggested many different kinds of arithmetic system as alternate way outs to deal with these problems and ways they could be implemented in computer hardwares. But the question have always remained, what fraction of population would have an inevitable need of such system? Well, that does not rule out the fact, though, that overflow and underflow is still a practical problem faced by many mathematicians and researchers in various fields of science like physics or statistics, etc. My project basically investigates a way around these problems using a different arithmetic system called the level index arithmetic system, and broadly speaking, concludes with an implementation of this system using Mathematica. As a result of which, now when computing a huge number in terms of size, maybe in fluid dynamics or in statistics, we can get some kind of meaningful result. Maybe not in the ordinary floating point system, but using which we can virtually abolish the problem of overflow and underflow in computer arithmetic. I would not go into further technical details as it would become a little boring for people who might not be interested enough after seeing this video. So everything is very thoroughly explained in my community post, and I would like to take it up from there in my poster session. Feel free to ask any questions if you have. See you at the conference.